So the optical center, no, this cannot be the center. The up one is bigger than the down one. Good. So this is F1, the same distance over here and over there. So this is F2. Same distance from here to here. 2F. Same distance. This is 2F. Okay. From the center, optical center to this is F. From the optical center to where the center of curvature, which is rebranded as 2F, is R. And here, R is equal to 2F, whichever way, either this side or this side. The radius of curvature is equal to 2 times the focal length. Gloria, R is the radius of curvature. This point is called the center of curvature. Are you okay?
So there is a center of
this point, which in mirrors we call as C, is called C. C now 2F is called the center of curvature. The distance from the center of the lens to where C or 2F is, this distance C to 2F is called radius of curvature, which we are representing by small letter R. Are we fine?
Yes, please.
Good. Now, and it is the same, please, the details as discussed is the same for when we have concave lenses as well. Okay, we have C, we have F, we have another measurement for F at the other side. This is F, the same 2F. F at the other side. Okay. The only thing is that for concave lenses, F and 2F, the focal point and then the radial center of curvature are virtual, because if I send rays that are paraxial rays to it, yeah, this will refract it. But the refraction always appears to be refracted from this point. So the ray would always appear to be refracted from this point. This one would also appear to be diverted or refracted from this point. So this is the focal point or principal focus. It's virtual. It's not actually there. It isn't actually there. Okay. Then if we have these are parallel rays hitting the mirror, or sorry, the lens. If we have, okay, if we have rays which are hitting this from a distance, yes, after hitting the lens, it would have to travel parallel to the principal axis. The refracted ray would have to go parallel. Is that parallel? Parallel to the lenses, to the lens, but appear to be, okay, the incident ray appear to be coming from here, or this diverted ray appear to be diverted from this point, F, which is the focal point. Okay. So when it is parallel, it will spread out, divert, and appear to be diverted from this point. When it is coming from a distance and hitting the mirror, the lens, the refracted ray will be parallel to the principal axis, and the diverted rays appear to be, or the refracted rays appear to be diverted from this point. And that point is what we call as the principal focus or the focal point. Okay. Are we fine? All right. Let's look at.
Please, can you go again? Can you come again?
Okay. Last one. Let me clear this side for the concave lens. So we have seen it for convex lenses or lens. Let's draw it for concave. So this is the center. Now, when you have parallel rays, paraxial rays hitting the lens, and don't forget this is concave. Okay, this rays would have to be diverted. After refraction, the rays will be diverted. But the diverted rays always appear to be diverted from a point behind it. So if you trace back the diverted rays, they appear to be coming from this point. This point is the principal focus, F. If it's coming from this end, the same thing. Then let's look at another situation where rays at far distance rays are hitting this. So let's draw another one. Concave. When the ray hits the optical center C, it goes undeviated. Okay. But this time we have the rays coming from afar, hitting it. Another one coming from afar, incidenting on the. It follows the same principle of reversibility. Look at this. Parallel, hitting it, it's diverted. Here it is diverted. When coming, the ray is diverted. So when it hits the ray, the lens, the concave lens, it has to be parallel to the principal axis. Look at this. When parallel, it went this way. So if it's coming in this manner, it has to go parallel. Okay. So the refracted rays would have to be parallel to the principal axis. But it appears to be this refracted, okay, rays appear to be refracted from this point when we prolong what is coming, where the two appear to converge is the principal focus. So it always appears as if these refracted rays are diverted or refracted from this point. Are we okay? So it's just the reversed form of the first one. When it's coming, it has to go this way. When it is coming in this manner, in a diverted manner, it has to go parallel. Please, are we okay?
Yes, please.
So for convex lens 2, let's draw something for convex lens as well. Hey, you can see, eh? Or you can see?
Not really.
Yes, please.
Oh, yes, really. Yes, really.
Oh, stage, yeah.
Okay, let me clear some parts and then.
Mr. Dia, don't clean it.
I know,
Oh,
I know.
Yeah.
I won't clear. Your pen is still there to draw. So let me change the marker. Else you will say not really. So convex lens. Okay. When the rays, paraxial rays hit it, after refraction, they will converge at a point. They will actually converge at a point. So this one is real, F. Now where we have if we have a point, either here or here, and the rays are coming from that point, so here it appears as if this point where the rays are coming from is the principal focus. The moment the rays hit the lens, they have to refract. But the refraction will be such that the rays will be parallel to the principal axis. Okay, so it is such a reverse thing. When the rays are parallel and hit the mirror, they will converge at the other side, principal focus. Now, when the rays are from the principal focus or passing through it, when it hits the mirror, the lens, the refracted rays would have to be parallel to the principal axis. So there, it's basically the reverse form of this and then this two. Are we fine? Are we okay?
Yes, please.
All right. Formation of images in lenses, similar to mirrors. But let's go through the 3 main rules for this game. Irene, can I clean?
Yes, please.
Stage, yeah,
Okay.
please wait.
But I'm sure you are done with this.
No,
Yes,
please.
please.
Mr. Dia, please, you said formation of what?
Images, okay, in lenses. Today you are quiet. Matilda, are you here?
Yes.
Matilda? Hey, it's been a while. Oh. Matilda, you don't even cough. Okay. Princess, are you there? Priscilla. Priscilla, are you here? So formation of images. Formation of images. It is the same as what we saw on the mirror. Okay. The 3 main rules There are three main rules in doing this, which applies to both convex and concave. So, a ray of light, this is F, another F, this is the optical center C. So another F, the measurements must be the same, please. So F1, F2, and its associated C, or 2F. A ray of light traveling parallel to the principal axis. After reflection, what happens? Yes, a ray of light parallel to the principal axis. After refraction, Ishra, what happens? Ishra? Pardon?
It will pass through the focal
The
point.
second principal focus or focal point. The second, okay.
Okay.
Ishra,
Yes, please.
I've learned you words or phrases to use. You have to pay. So after refraction, we'll pass through the second principal focus. Now, this is the first one. 2. The second rule we are going to use is that.
You said you.
Hello.
Please, what was the first rule?
A ray of light parallel to the principal axis after refraction would have to pass through the second principal focus. And that's what I've drawn on the board. Okay. Then the second rule, F1, F2. A ray of light from the first principal focus or through what do you think will happen? A ray of light from or through the first principal focus, what do you think will happen?
To be parallel
to the
axis.
Principal axis. Don't waste time. So it will be parallel to the principal axis. So once the ray is from or passing through the principal axis, the first principal focus, after refraction, the ray would have to be parallel to the principal axis. That's the second rule. Then the third rule. The third rule is this.
Please, the second rule.
The second rule is this. This is your lens. That's what they are in. Okay. So the first principal focus is here, F1. The second one is here. Let me increase it a bit. This is F2. A ray of light from or through, either it is from this or passing through this and hitting the lens. Here you can also rule a line to cater for incident rays beyond the aperture of the lens. So when the ray of light is from or passing through F, after refraction, it has to travel in such a way that it will be parallel to the principal axis. That's the second rule. Okay, the reverse form of this. Then the third and the final rule is this. The third and the final rule is that there's a center, optical center F1, F2. A ray of light hitting the optical center or passing through the optical center. Once the ray is through the optical center, it goes undeviated. So when the ray is through the optical center, it goes undeviated. So these are the three rules of the game. So let's look at image, how to use ray diagram to describe the nature of the image formed. Using ray diagram to describe the nature of the image formed. Here, please, for ray diagrams, we are always using straight edge. Don't use your free hand because you have to be taking measurements, okay? So I'll just clear this. Then take measurements. So I'm assuming that my focal length is equal to 10 centimeters. Presley, I won't buy it. I won't buy your. You have to find a way to recharge it, okay? So if F is 10, then the center of curvature must be 20. So take measurements. Marvelous.
Stating.
You are marvelously present. Okay, so this is F1, this is F2. Okay. Okay, so if this is F1, then F2 would be somewhere here. Okay. So this is 2F. Please do not use what I'm doing now. This is an 2F. So this is the center of curvature. Now, place the objects. Let's place the objects at 2F, at the center of curvature. Just as we've been doing in mirrors. Please, are you also drawing or you are looking at me?
Please, you are drawing.
If you are drawing.
Okay, then let's draw. A ray of light parallel to the principal axis after refraction would have to pass through the center, the principal axis. So this is my principal axis. Casey, are you drawing?
Yes, please.
So that's the first one. Then the second one, the ray must always come from the object. A ray of light from the object and passing through the center of the principal focus. After refraction, would have to be parallel to the principal axis. Here, when you are measuring, you have to be careful because if your line is not parallel enough, it can affect your ray diagram. So you have to gauge and then ensure that what you are drawing is really parallel. You see, it has to, the two rays would have to meet over here. That is not, meaning I suspect something is wrong. Let me check on my measurements. Let me use this to check my measurements to see what went wrong. From here to here, this is 10. Yes, the problem is from here. This measurement isn't correct. This is more than 10. So the moment you get that wrong, it affects your results. It affects the position of the image. So I have to measure again, clear my lines, and then measure again. So it tells us that that measurement super important. So let me take it again. If this is 10, okay, then 10 centimeter. This thing, when you are doing it all at once, 10 centimeter would have to be here. Okay, so this is 2F. Let's check that. Akovala.
Mr. Dear,
Please,
I had a network challenge, so I don't understand what is going on.
Oh, we are just using ray diagram to describe image formation, just as we did in mirrors. Okay. So you watch, you follow, because it's similar to what we've done on mirrors. Okay.
Yes, please.
Good. So I've taken my measurements again. We are placing the object at F. So the object is placed at the center of curvature. We are using ray diagram to describe the nature of the image form. So a ray parallel to the principal axis after refraction would have to pass through the center, the principal focus, the second principal focus. That's the first one. Then a ray of light from the object passing through the first principal focus. After refraction, would have to be parallel to the principal axis. And this is what I said. You have to watch and then be very sure that the ray is parallel, else it would affect your results. Look at where the two rays are intersecting. The point where the two rays intersect is where the image will be formed. And it is right at that point. It is right at that point.
Mr. Dear,
Hello.
Please, is the object on the center of curvature?
Yes, the object is on the place at the center of curvature. Okay, so you realize that, let's describe the nature of the image form. The image form here is real. 2 has the same size and position as the object. Two, 3, image is inverted. Look at something. Under mirrors, a real image is formed at the same side as the object. Under mirrors, when we talk about real images, they must be at the same side, position, okay, in front of the mirror as the object. When it comes to lenses, a real image must be at the other side, the opposite side. It's like a swapping. For mirrors, real images are at the same side as the object. Virtual images are opposite, okay, to the objects. When you come to lenses, it is the other way around. A real image would always be at the opposite side of the object. A virtual image will be at the same side as the object. Please take notes. Are we fine?
Yes.
So take note of the difference. And you see, when you draw it well, you get the image to be at the same position as the object, just as we saw on mirrors. Are we fine? Okay, any question?
Yes, please. Please, does it mean that the first 3 or the first 2 are the rules?
That 3, 1, 2, 3. There are 3 rules. Oh,
okay,
I think
so if I get to
I've cleared the last one. Yes, the last one is this. A ray of light hitting the optical center goes undeviated. When the ray passes through the optical center, it goes undeviated. So these are the rules of the game. Okay, we have 3 minutes for our 8 minutes wait. So let me quickly give you 2 positions to try whilst we are on that break. You are going to place the object behind 2F, behind the center of curvature, and place the object between optical center C and F. You are going to use ray diagram to describe the nature of the image formed when you place the object at these 2 different positions behind 2F and between optical center and then the first focal point. Are we okay?
Mr. please, I didn't understand it too.
Which 2F?
One?
The 2F, which one?
No, you see, we are always placing the object in first over here. Okay?
Okay.
Not at the other side. Unless we are left, okay, handed. So right, be placing the object from left, and then the light must go to right. So you are placing it in front. Then the image will be formed there, right?
Okay.
So who said she wasn't clear with what you've done?
Teacher, I was like, I'm not clear with what you were saying. Like, I didn't really get it.
What I'm saying is that you are going to try 2 because you are going to wait for the 8-9 minutes, about in about 1 minute time. So place the object behind 2F. Okay, this is 2F. Place the object behind 2F. Use ray diagram to describe the nature of the image form. When you finish, place the object between C and F and use the same procedure to describe the nature of the image form. That's what I said.
Okay.
Are you okay?
Yes, please.
So let's start right away. Please take your measurements well. Take your measurement and use straight
said-
edge. Hello.
What difference is the second one from the third?
Pardon?
The rules.
The first rule is that a ray parallel to the principal axis after refraction would have to pass through the second principal focus. The second one is that a ray from the first principal focus or through after refraction would have to be parallel to it, parallel to the principal axis. And then the third one is a ray of light hitting the optical center goes undeviated. So these are the 3 rules. Okay.
Okay, but the one up there is just the same as the second.
Yes, it's just the same as the second.
Okay, and then please, this ray diagram here is about if the object is placed on the center of curvature.
Yes. So